Alright, this is where things get intense. 3I, also known as Atlas, is acting in ways that even the most seasoned astronomers didn't see coming. And the strange part, it's not just about its speed, trajectory, or brightness. This comet is rewriting the rulebook as it drifts dangerously close to Mars. If you think you've heard all the hype about interstellar visitors, buckle up, because this one is on another level. Let's start with the most recent observations. Telescopes across the globe have been tracking Atlas as it enters its closest approach phase. Data shows sudden fluctuations in its brightness. Some nights it flares up dramatically, then dims as if hiding something. This isn't normal behavior for a comet. Most follow predictable patterns, brightening as they shed gas and dust while approaching a star. Atlas, on the other hand, is pulsing like it's alive. NASA scientists reported inconsistent energy signatures, which suggests something more than ice and rock is going on here. And here's where the red flags start piling up. Instruments have detected unexpected acceleration in Atlas's movement. Normally, comet acceleration can be explained by outgassing, jets of gas pushing it like thrusters. But Atlas's acceleration doesn't match the visible activity on its surface. Simply put, the math isn't adding up. This exact type of anomaly sparked years of debate with Oumuamua, another interstellar visitor, which led some to wonder if we were dealing with artificial origins. With Atlas, the pattern is eerily familiar, but on a larger, more dramatic scale. So why does Mars matter in this story? Because Atlas is projected to pass within a strikingly close range of the red planet. While Earth isn't in immediate danger, the Mars pass raises major questions. If Atlas fragments or its path shifts slightly, the debris could interact with the Martian atmosphere, satellites, or even the rovers stationed there. Agencies like NASA and ESA are quietly running simulations, assessing what a worst-case scenario might look like. Could it slam fragments into the surface? Could it disrupt orbiting spacecraft? Even if the risks are small, the implications are massive. Now let's rewind for context. 3I Atlas wasn't the first interstellar object we've tracked. Oumuamua in 2017 sparked theories of alien probes. Borisov in 2019 was a more typical comet, though its speed and path confirmed its interstellar nature. But Atlas combines the strangest elements of both. It's long, narrow, and rotating oddly, like Oumuamua, but it's also trailing material like Borisov. In short, it doesn't fit cleanly into any category. Astronomers are saying openly that Atlas could be the most bizarre interstellar visitor yet. Here's a detail most people miss. The way Atlas reflects sunlight doesn't align with its expected composition. Spectral scans show unusual mineral traces, not just the standard frozen gases and dust. That raises questions. Was Atlas once part of a planetary system with conditions far different from ours? Could it carry material we've never studied before? If so, studying it as it nears Mars could unlock data we can't get anywhere else. Let's talk about the mystery of its breakup. In early monitoring, Atlas showed cracks and possible fragmentation, like it was coming apart under solar pressure. But then, against expectations, it seemed to stabilize, almost like something held it together. Normally, comets under that kind of stress disintegrate completely. Atlas didn't. That resilience sparked whispers. Could there be more structure beneath its surface than we realize? Meanwhile, the public reaction has been explosive. On TikTok, threads about Atlas pull millions of views, with theories ranging from alien spacecraft to secret government experiments. Reddit forums are filled with users posting Skywatch data, comparing brightness logs, and speculating whether Atlas is a comet at all. And the hype isn't entirely unfounded. When multiple observatories confirm anomalies, the line between science and speculation gets very thin. But let's ground this in science. Astronomers are split between natural explanations and the possibility of something extraordinary. Some argue that Atlas's strange path is due to a complex spin that alters its outgassing. Others think we're seeing material interactions that we haven't modeled before. But then, there are those who point out that the scale of its anomalies mirrors no known natural object. A group of Harvard researchers, still famous for their Oumuamua alien probe theory, have already hinted at Atlas possibly belonging to the same class of objects. That doesn't mean alien ship, but it does mean artificial or unknown origins are still on the table. Adding another twist, Mars itself becomes part of the mystery. Atlas's trajectory means that Mars-based instruments, like those on Perseverance and Curiosity, could capture unprecedented close-range data. Imagine rovers looking up and recording fragments entering the Martian sky. If Atlas sheds material during its pass, we could analyze dust composition on another planet for the first time. That possibility has scientists quietly excited and nervous at the same time. Now, about those comparisons to previous visitors. Oumuamua was silent, a single flash across our system. Borisov was chaotic, but predictable. Atlas is interactive. It reacts in real time, showing behavior changes that even short-term predictions can't fully capture. Astronomers recalibrate its trajectory models almost daily. Each update brings new surprises, fueling the debate about what this object really is. Some reports even note radio silence tests. Radio telescopes have scanned Atlas for signals, and while nothing artificial has been detected yet, the effort itself shows how unusual scientists find this comet. It's rare for multiple international agencies to commit resources to monitor one object so heavily unless something big is at stake. And then there's the looming fear. What if we're underestimating the risk? While Earth is safe, the potential for Mars impacts isn't fully ruled out. Some fragments could alter orbits, drift unpredictably, or even redirect closer to Earth in decades. Planetary defense experts stress that even a small chance of impact must be studied seriously. If Atlas breaks apart in unexpected ways, the debris field could last for centuries, complicating future missions to Mars. Now let's look at public communication. NASA's official updates have been cautious, using phrases like unusual activity and unexpected trajectory shifts. But behind closed doors, insiders suggest the language downplays the reality. Independent astronomers have leaked data showing Atlas deviating further than early predictions suggested. That's why the internet is buzzing with theories. When official statements stay vague, the public fills the gaps with speculation. Meanwhile, conspiracy theories are thriving. Some claim Atlas is a disguised probe, launched by civilizations light years away. Others suggest governments know more than they're telling us, and that Mars might already be preparing for a direct hit. Whether you believe them or not, these theories highlight the growing distrust between institutions and the online community. Here's another overlooked fact: the heat signature of Atlas. Observations show variations that don't match simple comet heating. Some parts glow hotter than expected, as if internal processes are at work. Could it be trapped radioactive material, or a surface composition unlike anything seen before? Either way, it's another piece of evidence that makes Atlas stand out from the thousands of comets we've cataloged. Let's not forget the timeline. Atlas is set to make its closest pass to Mars in the coming months, and every passing week brings sharper telescope images and richer data sets. As we inch closer, astronomers expect even more strange behavior to emerge. Some have already said Atlas could become the most closely studied comet in recorded history, with attention levels rivaling Halley's Comet and even the first images of Oumuamua. This moment could rewrite what we know about interstellar visitors. And if you want numbers, here they are. Atlas is estimated to be several hundred meters long, stretching across lengths similar to downtown city blocks, and moving at tens of kilometers per second. At that velocity, the kinetic energy is so enormous that a direct hit on a planet would release energy greater than the largest nuclear tests ever conducted on Earth. Even small fragments, no larger than an average sedan, could smash into satellites with the force of high-grade explosives or gouge the Martian surface with craters visible from orbit. That's why every tracking station and planetary defense office is treating this object with the seriousness of an active threat scenario. Not just Curiosity. Agencies are building detailed impact simulations, cross-checking orbital shifts daily, and preparing contingency studies to ensure human missions to Mars are not blindsided. It's planetary defense in real time, with every update reminding us how thin the margin of safety can be when interstellar giants cross our path. So where does this leave us? With a comet that behaves like no other, heading straight past Mars, carrying mysteries that scientists can't fully explain. Whether it's a natural outlier or something far stranger, Atlas has forced us to rethink what interstellar visitors can be. The next few months will decide whether it becomes just another comet in the record books, or the object that redefined how we view our place in the cosmos. Whatever Atlas really is, one thing is certain: the story isn't over. Each new observation, each new anomaly, pulls us deeper into the mystery. If you thought Oumuamua was weird, wait until you see how this one ends. Stay tuned, because the secrets of 3I Atlas are only just beginning to unfold.